Good afternoon, everyone. I'm Priyarsha Vallabhanini, and today I'll be sharing my experience and takeaways from Grace Hopper Celebration 2024. This presentation will highlight my journey at GHC and reflecting on what I learned and how it shaped my perspective in the tech field. My Grace Hopper journey began with a scholarship from the University of Arizona, which I was honored to receive alongside six other students from the College of Information Science. And on the morning of October 8th, we collected our GHC badges. It's a small but vital step as entry required it, and losing it meant a $250 replacement fee. Later that evening, the opening ceremony set the tone for conference. Mixmaster Mike performed a breathtaking DJ followed by a soulful performance by Mary Lambert. But what truly stood out was the opening plenary, led by Brenda Darden Wilkerson, President and CEO of Anita B. Org. Her message on Me Plus We, the collective power of women and non binary technologists to drive innovation and change, was both empowering and thought provoking. The Career Expo at GHC was an incredible experience that required strategy and adaptability. As part of the Yellow Group, I attended sessions across 3 days. On October 9th, I observed how companies engaged with attendees. This helped me plan for the next day. So on October 10th, I focused on the top tier companies like NVIDIA, Meta, Google, and Morgan Stanley, and so on, while also exploring smaller firms. It was a productive day of conversations, learning about work cultures and understanding the opportunities available. By October 11th, I noticed a few changes in the list of companies attending, and so I adjusted my plan and covered as many as I could. Most of the companies asked for resumes to be uploaded online and to join their talent networks, while a few accepted them in person or conducted on spot interviews. Overall, the expo was not just about resumes, it was about building connections, gaining insights. Grace Hopper taught me how important it is to make the most of every moment. Instead of focusing only on the expo, I realized the smaller, less highlighted sessions often held hidden gems of knowledge. So, engaging in discussions during sessions or simply observing the dynamics of networking events provided unexpected insights. These moments reminded me that every corner of the conference had something valuable to offer if I stayed curious and open minded. Another lesson was that every story matters. Hearing the journeys of others, from speakers to fellow attendees, wasn't just inspiring, it was a lesson in perspective. It made me reflect on how diverse experiences, even those outside the spotlight, play a vital role in shaping innovation and collaboration. These stories reminded me that there's strength in our differences and that my journey is just as meaningful. Lastly, preparedness. It's something I'll prioritize even more in the future. Researching companies beforehand and registering for one on one recruiter sessions could have opened up even more opportunities. I also learned to ask specific questions about the recruitment process. Those insights can often give you an edge that goes beyond what's listed on the job boards. So, if I have to share some advice for future attendees, I'd start with this: plan ahead. Grace Hopper is massive, and the more you prepare, the more you'll gain. Research the companies attending, their open roles, and register early for one on one sessions with recruiters to secure better opportunities. Also, prioritize sessions that align with your goals, but leave room for spontaneity. You might stumble upon something unexpected and inspiring. Next, comfort first. Avoid carrying heavy bags, stick to essentials like snacks, a water bottle, and all. If possible, go minimal or bag free, as moving around too much can quickly become tiring, and comfortable shoes are a must. Strategize your visit. Start with the companies you're most interested in to avoid long queues later. Once you've covered your priorities, explore booths with smaller lines. Build connections. Engage with as many people as possible, from recruiters to peers, and try to add them to your LinkedIn soon after. Building these connections can open doors you might never expect. And most importantly, enjoy the process. It isn't just about the outcomes, it's about immersing yourself.
Yeah.
Thank you for joining me.
So good afternoon, everyone. My name is Rianshi Bora, and I'm currently a research professional working at the Hum Lab, currently pursuing my master's in data science. And today I'm very excited to share my project titled Socioeconomic Analysis of Playground Shade Structures, supervised by Dr. Chris Lim at the Zuckerman College of Public Health. So this project basically explores the intersection and the relationship of geospatial computation and socioeconomic disparities to address a very, very important environmental and public health concern. So the agenda for today will be very straightforward. I'll start off with the overview of the project, proceed to the methodology, examine the results, and then conclude with future directions. So yeah, the project focuses on understanding the disparities in playground shade structures in schools by combining high resolution imagery with socioeconomic data. So using machine learning and image classification techniques, I classified the shaded areas of schools and analyzed their connections to variables like income and demographics of that particular census tract. So the key tasks, they included data collection and data pre-processing using NAPE imagery and the socioeconomic data sets. Then there was the image classification of playground shade structures. And finally, the statistical analysis of the classified data, which was the result, to get significant insights from it. So the data sets that were used were mainly three. The first one was the NAPE high resolution imagery for geospatial computation in Google Earth Engine. Second was the demographic and the socioeconomic data from NCES and CCD. Third was the global settlement layer data, which gives you insights into the urbanization patterns, the built up surfaces, and the structural metrics of the buildings. So the next step, the main step, was the image segmentation and the classification. The approach was to train a random forest classifier on segmented superpixels from a simple non-iterative clustering, or SNIC. So the training dataset consisted of 750 samples across three classes mainly, which were grounds, non-playground shade, and playground shades. I used several features, including spectral indices such as NDVI, NDWI. Then there were structural metrics such as building heights, thermal insights, and then texture analysis using contrast and entropy features. This is basically, here you can see the classification results with red indicating the grounds, blue representing the non-playground shades, and the green highlighting the playground shades. So it gives you a pretty good idea of how the model is accurately classifying the school areas into the respective classes, which was required for the analysis. So for the accuracy, the model achieved an overall accuracy of 87.2% with a kappa value of 0.7602. And the main metric for our purpose was the consumer's accuracy for class 1, which was the playground shades, which was also the main variable of interest. So while these results are very promising, we have identified ways to further improve the accuracy by doing feature engineering and adding additional variables to the model, which is basically the next step of the project currently. So yeah, for future plans looking ahead, I plan to optimize the model further, expand the data set to include the school data from Texas as well, which would help do a comparative analysis across the states, providing us with hopefully a deeper understanding of the shade distribution and the model accuracy. And I also aim to publish a research paper giving all the methodology and all the insights, and hopefully contributing to some advancements in the public health domain. So yeah, thank you everyone. Thank you for giving me the opportunity to present today at the talks. And I'm very excited to hear about everyone's projects and experiences. I did attend the GHC as well, but I'm sure there are other people with so many different perspectives that you'll all get to hear about. And if you have any comments, questions, or feedbacks regarding my project, please feel free to reach me out at the contact information on the screen. So yeah, thank you everyone, and thank you so much for this opportunity.
Hi everyone. I really can't see anyone who's sitting there, but hi everyone who is there and who has joined Zoom. And I'm really glad that I get to do this right before I'm graduating this fall 2024. So this presentation is mostly about the key projects that I have done through my master's journey. Fortunately, I have got to work in 6 research projects throughout my 4 semesters and 2 summers in data science. And I'm just here to talk about the key projects that I've done. So currently, I'm working at Aztec College of Medicine, where I'm developing a virtual patient. The AI virtual patient. Right, we started off with building it with a Soul Machines avatar. We built the AI virtual patients using the avatar that is available to us in Soul Machines, which is basically a 2D avatar. And then Soul Machines also provides us with an orchestration server configuration where you can develop your own backend application and connect it to the avatar in Soul Machines. So the conversation logic will be basically your application code. So we have managed to use GPT as our LLM model to develop a conversation logic for our virtual patient in Soul Machines. And then we moved on from there to, so this, uh, the images over here actually shows that our backend logic with the LLM GPT has like a memory capability and a session awareness for the virtual patients, where they know what questions we asked them, initially, like previously. So they have a memory capability of that, and they are very consistent with their responses. And then we are also developing a RAG database for these virtual patients where we can get more dialogue authenticity with them. So and then now we wanted to develop a 3D virtual patient where we wanted the patient to move around in a hospital kind of environment. So we moved on to Unreal Engine and used MetaHuman's avatar in Unreal Engine to build the patient. And we haven't gotten to the part where we connect our Node.js backend to the Unreal Engine yet, but we are using Convey AI, which is also a conversational AI, to connect it to the Unreal Engine. They're also using LLMs like GPT and Llama and they have all kinds of LLMs that is attached, connected to this conversational AI, and you can just pick and choose whichever one you want. And we are planning to integrate an SQL database to this as well, where the avatar, when it gets a question, it can just pull the data from the database and answer to the questions. So that is my current project. And then before this, over the summer, I worked at AI Core as a lab manager, and I tried to mentor and guide 60 interns through a summer internship program. And that is where I got into this avatar technology and, building AI assistants and everything. And working as a mentor and as a lab manager, it really got me feeling like, my work is not just my own, it's the work of the people I mentor as well. So that was a very, changing experience for me. Um, yeah, so this was my first project at the University of Arizona, where I developed a segmentation program for carpal tunnel syndrome diagnosis. So we wanted to try to see if we can get a higher accuracy than the already existing systems, which had like a dice score of 0.85. And we managed to achieve a dice score of 0.89, which was good. And we did this by collecting data from 100 subjects of the carpal tunnel anatomy. It was all ultrasound images, and we tried to do a segmentation of the median nerve and carpal tunnel, the TCL ligament. And you can see the results in the image over here. And this is how close we got to segmenting that from the ultrasound. And we did all of this in LabVIEW programming, and the morphological parameters were calculated in Python though. And then I worked at the Biosphere too as a data analyst. And I had a really amazing mentor who taught me all about data pipelines and how to get data from database, manipulate it, process it, and push it back to the database. And that is basically all I did at the Biosphere 2. And before I came into doing this, before the pre-processing part was all lines and lines of Python code. It was all done manually through an Excel sheet by my mentor. And I came in and I automated all of these processes by reducing the time by like 70 to 80% almost. So yeah, these are some of my experiences at University of Arizona. Beyond this, I worked at the College of Nursing, and I am currently working as a graduate research assistant with Dr. Angela Cruz, who's also an amazing mentor. And we are researching on how to implement ethical AI in educational settings and try to reduce, policy making systems. So yeah, those are my experiences. Thank you for giving me this opportunity to, present this right before I get to graduate.
So, very good afternoon to one and all present here. So, myself Danya Priya, and I'm pursuing my master's in data science at University of Arizona's College of Information Science, and I will be graduating by this December. And I'm very glad that I got this opportunity to present this lightning talk series for this fall semester before I graduate. Yeah. So today I will be walking you through and discussing about my project work as a part of an internship at University of Arizona's Research and Innovation and Impact. So bear with my voice. My voice is not good. So here, enhancing the geospatial research by building the community catalog for the Google Earth Engine was the main priority goal. And here, first of all, I would like to just give a overview of what the community catalog is all about. So we have built the awesome GE community catalog, which is unfunded open source grassroots level project, which is a mission to help the community sourced and the community generated geospatial data sets to put together. And our goal is to make the data sets so accessible to the geospatial researchers and the analysis platform, fostering accessibility and reducing the digital divide. So this catalog will serve and lives across alongside with the Google Earth Engine data catalog. And this is a collaborative effort which makes us the pre-processed research data sets to be put into a single place. And it also allows us to request the open sourced licenses data sets as well. So here, the first data sets, it's all started about with the Facebook's high resolution population density maps. So first of all, the people will be very eager about this particular data set. So first data set which we have inculcated in our catalog was the Columbia University's population data sets. And the challenges that was like the scaling the data management. So the day by day, the data sets were so huge, and the scaling of the data management was a pretty challenging task for us. So this is how the catalog, this is how the catalog which looks like. So here we have uploaded all the data sets in at one place. So the problem was like it was not a stack compliant. The stack is yeah, I will be letting you know what the stack is all about. So the value of why do we need all those community data set is like, so the researchers can easily access all the data sets at one place. So these data sets include the data sets on the climate, land cover, and high resolution data sets, and settlement layer data sets, population density, and all data sets which is related to the geospatial are available at one place. So the stack compliant is like the spatiotemporal assets catalog. So this is a specification that is meant to prepare a catalog in such a way that we have to follow all the rules and regulations of how it has to be organized, and how the licensing should be there, and these are all some specifications it has to be followed. So my work was the standardizing the data sets, and creating the APIs, and automating the uploading of the geospatial datasets into the catalog, and I have reduced the manual effort by 40%. And so the final process is like now the API integration is on the way. So here once if we implement the Stack API, so it will be easily integrated with the Google Earth Engine. So till now, I have streamlined over 1600 plus data sets, so which is of huge size. So I would like to share how it looks. So yeah, as of now, you can able to see like it is growing over 500 TBs of the size of the catalog, and images and other stuffs have been increasing day by day. So I would like to show you a sample data, like how the California forest looks like. So this is the Stack browser. So it will do all the validation part, how uh, the catalog has to be there. So it should give the validation. It should give the report so that it should be validated such that it has been accomplished and followed all the Stack compliant and Stack rules. So this is how the catalog looks. So it is a Canada's Landsat derived forest harvest disturbance. It is from 1985 to 2020. So if you can able to see the licenses, and it is a temporal extent, how far it is being spread out. And this is the map in which you can able to see the harvest from those years and the timelines, and the general other informations are all been here. And you can able to download the research paper related to that DOIs with the citation information, and as well as the you can download the data sets as well. So, and one more thing is I just integrated it with the Google Earth Engine. So if you can click here, it will just go ahead with the Google Earth Engine, and we can able to edit it here in the editor. Yeah, it is just for this, it has been integrated very well. So likewise, I have to do for all other data sets. So the work is going on. So this is the stack. So I would like to thank the Dr. Tyson Schwetnam and the Dr. Sam Priya Roy for giving this opportunity. So without them, this would never been possible. And then I would like to thank my advisor, Christian Roman and Holly Brown, Dean Catherine Brooks, Jennifer Bates, Jana and Simon Button for all and all my professors who have supported me all throughout my all walks of my master's journey. And I thank everyone, each and everyone. Yeah, thank you so much for giving this opportunity.
Thank you, Dania.
Hi, I'm Kashyap. Can you move closer to, yeah, just the mic. Okay. Okay. Hi, I'm Kashyap, and I'm a MS in data science student. I'm also an AI engineer at AI Core at the university. And my topic today is automation through AI. I'm gonna give 3 examples of work that I've done over the last few months. The first example, in the summer, I did an internship at a company called Archili, which is a resume parsing company. And they gave me the project of creating a compliance form filling application. And what it does is basically a user should be able to upload a document. The application should retrieve all the questions from it. And then based on the company's compliance documents, the standards that they follow, and basically all the compliance that they follow for their product, the bot should answer it based on that. So I created a retrieval augmented generation technique model where each question is sent to the large language model with context related to the question, and it answered based on that particular context. And then the app would subsequently fill each question and give the user the filled out document. So this was my experience in the summer. This is a project that a personal project of mine where I wanted to create a data analytics app integrated with AI in a way. So I called it Data the Explorer, where you can upload a data set. Yeah. So the user has options from doing EDA, data cleaning, pre-processing, running machine learning models, and generating visualizations. So the idea was to create an automation or a tool so that users can do these at a much quicker rate. And the feature that I want to showcase today is the interactive visualization, where I'm providing a small sample of the data set to the large language model along with some key statistics, and then asking it to generate visualizations based on that. And the idea was for the language model to generate code also for the visualizations and running that in real time in my environment. So these are generated by the large language model. And what I'm doing next is providing the visualizations themselves back to the language model so that it has contextual understanding of the data, and then it'll understand the underlying patterns, which can then be further used for analysis in the next step. So this is the first. So yeah, this is one aspect. The other aspect would be, I guess, running machine learning models. So you could run a machine learning model and it will the application inputs the result to the language model for interpretation. And it'll be able to tell you what changes you can make for a better result. So this is my second use case for automation through AI. The third example that I wanted to showcase was a project that I had an idea for earlier this semester. And it is basically using prescription images, handwritten prescription images, and basically to extract text from that and pass that along. My idea was to pass prescription information along with, say, patient health history, couple that and pass that on to a language model which is medically very aware and medically accurate, and then automate the process of report generation and also empower a patient to ask questions, ask questions about their own medication, risk analysis, to check whether their past dosage and their current medication match up or if there's any conflict. So that was the idea, and I'm still working on it. But these three are examples for automation in AI that I've worked in the last few months, and I see that the future is going to be a lot of integrating a lot of applications like this into existing tasks and workflows. So yeah, that's my presentation. Thank you.
Thank you very much to everyone who is here and on Zoom. And like the previous presentations, this is a starting project. So these are the seminal stages of the project, what I try to be or what I intend to be my capstone project that I will develop the next semester. I've been working on these initial stages with Dr. Javier Osorio Sago, political science, and I'm applying data science and computational social science tools, combining them with political science and basically social sciences methods. So at this stage, I am mostly in the process of acquiring data and cleaning data and trying to know what to do with the methodology and which variables I'm using. So first of all, the background. I'm trying to understand how extortion or why extortion has grown so quickly in Peru in the last few years, between 2019 and 2024. As you can see, I'm using news as a metric. And by 2019, there were only 115 articles published containing the word extorsión or extorsionadores in Peru, which is extortion or extortionists. By 2021, the number was 421, and in 2023 it was 2,735, and this year is even crazier. Is almost, I believe it would be close to 5,000 news containing those words as of now. But because in Peru, the media is controlled on an 80% by the same group, and I wanted to see if this was just something that was due to that nature, I contrasted it with data from the police, and the trend is exactly the same. So this is national data, this is national news. This is national reports to the police about extortions, this is national news or news circulating. So there is a correlation, as you can see here, by the person correlation index, and this is a graph that shows exactly the same curve, exactly the same pike at the same time. So why? My question is, why this is happening? And these are maps, not at the national, or these are graphs, not at the national, but at the department level. The departamentos in Peru are what would be states in the United States. But because we are not a federal country, we don't call them states. But you see also similar trends in similar years in some areas and not in others. So that's my other question. Why in some areas more than in others? And my periodization is also quite simple. It's 2019 to 2024 because COVID. So COVID helps me, COVID works as a baseline because during COVID, Peru was paralyzed. So everyone was sheltering in place, no one could go out. And I'm using 19 as a -1, let's say, and the years 2020 and 2021 as ground zero. And also because for social scientists and historians like myself, I'm a recovering historian actually, crises reveal a society's structures. So when there's a crisis like the one the pandemic created, everything is fleshed out, the good and the bad things of a society, of a country, of a political structure. So my research questions, as I was already stating, why has the number of extortion crimes increased so dramatically in the last few years, and what micro and macro dynamics have favored the proliferation of extortionists in Peru between 2019 and 2024? And these are my secondary questions that had to do who the extortionists are, where are they coming from, where are they located, and who the victims are. Well, are we talking about high-rank business people, middle-rank business people, or just the owners or the store around the corner, of the convenience store around the corner? Who are the victims and who are the perpetrators? And basically, my general hypothesis is that organized crime, that is gangs, basically, emerges as a product of state weakness and inequality. So a weak state, a weak that is unable to provide the basics to their citizens, in this case, security, will favor the growth of this type of crimes, and society characterized by inequality will also be more prone to these types of crimes to arise. So basically, that favors the growth of organized crime. And but that general hypothesis is not enough to explain the spike that we see around the years 2021, 2022. And so I expanded my search to other trends, to other words that began appearing in the news. Sicariato, that is the crime of being a hitman. So assassinations committed by hitmen, that is paid assassins. Agua, that is, you might not be familiar, but it's a Venezuelan gang that has expanded international and is even making headlines here in the United States. And the combination, so my search for news was also the combinations of words using a Boolean query. Sicariato and extortion and Venezuelans, I will later explain why, and extortion and foreigners. Oh, sorry, it's the other one. These are my secondary hypotheses. So although extortion crimes are the product of state weakness and inequality, as I said before, the spike in 2022 results from the penetration of the Venezuelan gang El Tren de Aragua, whose rapid expansion is also due to state weakness. And because in the previous table, we can see the same trend in news growth happening for all these things at the same time, I'm extrapolating that hypothesis to explain that this is also applied to hitman crimes, and that basically, in a very general way, when what's the word I was using? Sorry. Higher crime rates happen in a country is not only because there is state weakness and inequality, but also because there is a push factor from the outside. And this push factor from the outside is the penetration of this Venezuelan gang. And this becomes a vicious circle because that state weakness favors the penetration of this external force, and that external force makes the state even weaker. So basically, I've been collecting data from Nexus Uni. That's
roughly you're past the time.
Okay, sorry. So basically, yeah, my data is from news and from state sources. And my methodology in the data science realm is a combination of data and computational social sciences methodology. I'm using Conflibert, that is a transformer-based algorithm for conflict and violence, to trace conflict and violence group. I will use this for named entity recognition and in order to geolocate violence and the spread of crime. And I will also use topic modeling to say trends that I might be missing in the data. But at this point, I'm having more basic problems that are not related necessarily to the data science part of the work. How should I measure state weakness, corruption, or what? How should I measure inequality, especially when these crimes are happening in urban areas, and it's not that there is no electricity or water or running water, etc., but how to measure inequality, and what's the right way of assessing causality here? I'm using so far DAX and multilinear regressions, but I'm still unconvinced that these are the right ones. So this is what I have to show. Again, these are the seminal stages of a project in which I'm trying to combine very technical tools with very theoretical grounded tools. And thank you.